So today I will talk about the variable control charts. So this one is from our previous lecture that I talked about. This one is for statistics. Because it is like we are building this, today's lecture is more heavily based on the previous lecture. So we talked about the sample population and the diagrams and also some statistical terms. And also we talked about the central limit theorem. You had the homework on it. This one is very important. And then today I will talk about the variable control charts. And then I will talk about the causes of variation, the X-bar chart, the range chart, and then we have the patterns in the charts. So this one maybe will be part of your homework. I will not cover a lot, and then we will have the S chart for today. And also I will talk about the outliers. If you have an outlier in the chart, how you are dealing with it. The outlier means that you have the data points that so if you have the data points that they don't follow the trend, then we call it the outlier. So this is the outline for today. And then if I start slowly, then we have the variation in the process. The variations can be within the part. So if you have a part, for example, the part itself may not have the uniform surface roughness. This is the bearing that you can have for example, this part is rough, and then this part maybe it is smooth. So we have the variation inside the part. We can have variation from the piece to another piece, but it depends on it should be manufactured at the same time. We have the 3 gear bearings here, you can see, and they say that this one has a diameter of 17.056 mm, and this one has a diameter of the 17.05 mm, and this one has a diameter of 17.058 mm. This is another possibility that we have a variation inside the part. So because we are trying to deal with variations, so how we are trying to control it, how we can control the variations. But first we have to see that there is a variation, and this is the reason that we have the control charts. If I go back, the control charts here, it means that the control variations. So we are trying to control the variations. So we can have variations from time to time. So it's possible that the part that you manufacture early morning, it is very different than the part that from the late afternoon. The number of products may be different, or the dimensions of the parts. So there are lots of factors that affect the variations inside the part. So this one is very important, that we have variations. This is the first thing that we have to keep in mind. In manufacturing process, as we said, why do we have variations? So the first reason is that none of the manufacturing process is under 100% controlled environment. So what it means is that, so you can have change in temperature, you can have change in the pressure or the working conditions. None of the product is exactly the same of the other. So we have the random errors that create variations. These random errors, as the name says, they are the random, and then they cause variations. These random errors. And then it can be you have a change in heat or the temperature. You can have background electrical noises, and these are random. And then you can have the variations due to systematic errors. These are also cause variations. These systematic errors are the errors due to the measurement itself. For example, you have the voltmeter that shows 1 volt, even it is disconnected. So you have a problem with the voltmeter itself. So it creates a measurement error, and that affects the variations in the manufacturing process. So, or you can have the measurement in cold temperature, you have different result. In hot temperature, you have different results. Or we have the scales that do not account the gravitational acceleration. So this way we have the variations. So in manufacturing process, the sources of variation. So the problem is the variation, yes. The source may come from the materials. It may come from the methods. And it may from the machine or equipment, you can say. And then it may come from the people. Okay, so we are trying first to identify the source of variation. This is the aim. And then after identifying the source of variations, then we will try to build a chart for those variations. And then we will try to control the process. And the main problem, for example, from material, you can have different specifications material, or you can have moisture content. You cannot, you may not have the best finish in the materials that may create the variation. The methods will also affect that they can create, like you have the time problem, you have a delivery time problem, you have too many machines working at the same time, so that it creates the variations. And all of, as I said, the machines, they are not 100% identical. So none of the machine is 100% identical. So therefore, you will have the variations in product. So this may be the product size, product dimension, whatever, we have the variation. Or equipment size, it may be that electricity connection or the wear in the tool, the maintenance problems, and the people also, the people are not qualified, they don't have enough training, and the errors from the operators, they can create the variations in your products. So these are the sources of the variation. So first we are trying to identify what is the source of the variation. So the second thing is that for any variation that we have in the manufacturing process, if we can control it, we call it as a state of the statistical control. This one is important, that you are controlling in a statistical manner. So otherwise you call it a stable. So if it happens when we have the causes like random causes. For example, you have the power cut, and this power cut creates, so what it can create a problem like, for example, the number of products. And this is the random cause. And then this type of the sources, this type of problems, you can control it, because next time it will not happen. It happens only once, and you know the source, and you know the reason, you can solve the problem. What is the problem of the power cut? And you can solve it. These are random, but you can control it. Or the temperature variations, you can control the temperature inside the room by some addition sources. These variations due to random causes, these are predictable and then controllable. The second one is the unstable variations, and then these are the outside, like you have defective raw material, so this affects the whole process. Or you have the negligence of operators, you have the tool wear. So these type of variations you cannot control, and then this is an unstable process. So, but we are more interested in the variations that we can control or that we can decrease. So the aim is that, so we are trying to control variations. If we can control the variations here, I mean the change in product specifications, product features. So for example, as I told, you have the bearing. So you never have always the same diameter for the bearing. So this type of variations you always have in the manufacturing process, and you are trying to control it. So these variations have the cause. As I said, the cause may be the random, and the cause may be the assignable. If the cause is random, you can control it. Control is possible. If the cause is assignable, you cannot control. Here you cannot control the operators, but you can control the temperature, you can control the power cut problems. So if you have a variation, and if the cause of the variation is random, then it is good that you can predict and control it. If you have a variation in the product, as I said, the geometric variation, it may be the, for example, surface roughness variation, whatever, yes, whatever variation you have, if the cause is assignable cause, that, like, for example, defective raw materials, you cannot control it anymore because you have it. So that's the thing. But what we are trying to do is that we are trying to control it. So the random causes are good for us. So the control charts, which will be main topic for today, is the charts that is used to control the process. So we are trying to control the process by the control charts. So this is the main topic for today, because for any process, we have inputs and we have the outputs. It's like the function. So for this process, we are trying to control it. So why do we want to control? That we are trying to control to decrease the variation. So also this one, you can decrease the variation. You can also increase the manufacturing capacity. This is also affecting, yes, you can also look for it. But the main aim is that, so how we can decrease the variation in the product. This is the main essence of the control charts. And the variations, I gave the examples here. Yes, the product features are not always consistent. So we have three types of the control charts. One is the X bar chart. This is the average or the mean. We have the R chart, and this is also called the range chart. And then we have the S chart, which is also called the standard deviation. So these are the three types of the control charts that we are using. So let me start first from the X bar chart, this one. And then I will move on to R chart and the S chart. Okay. Say that you have it may be that you have the fire extinguisher, yes? And this fire extinguisher, it should have a pressure that is, that is safe, so that you can use it. And then fire extinguisher, let's say the manufacturing. So for these fire extinguishers, you are trying to check that how the pressure is changing from one fire extinguisher to another one. So you are taking samples. So say that sample 1, you are taking 4 fire extinguisher and check the pressure. Sample 2, you are taking again 4 and then check the pressures. So this is for example fire extinguisher 1, you check the pressure, it is 12 point something psi, and second one you have the 12 point something, and then 11 point something, and 14 point something. For the sample 2, you do the same, and then you check the pressure. So you have the 4 fire extinguisher here, 4 fire extinguisher here. And then similarly, you have the 4 of them here. So overall, you have the 23 samples, and sample here, it's also called the subgroup. And you have 23 subgroups or 23 samples, and for each sample, you have 4 measurements. And then you are trying to understand how the pressure of the fire extinguishers changed from one to another. So you are trying to see the variation. Which one is acceptable? You can say the final question may be that, which one is acceptable? And then which one is not? Or you are trying to see the variations in your product pressure. Because you have to have some, I mean, this one depends on the tolerance, yes? You have to have some tolerance that is okay for the pressure values of these fire extinguishers. Okay. For this one, we have the, as I said, we have the 3 charts. So we have X bar chart, we have the R chart, and we have the S chart. So we can use, so when you're trying to use, you can use X bar and the R together, or you can use the X bar and the S together. So at the end, you will identify which product is acceptable for manufacturing process. This is not like looking at it, okay? You can look at it and say that, okay, 11 is low. I mean, 7 is very low. I cannot, I mean, this one means that this product is defective. It is not that way. You have to look from scientific point of view that which product is in the tolerance range and which one is not in the tolerance range. That this is how you are doing with the control charts. So this is the product that we did, the pressure measurements. And first I will start from the X bar chart. And this X bar chart has the upper limit, and this one is the UCL-X. This one is upper control limit. And we have the, sorry, this one should be L. Let me correct it. This one has the lower control limit. So we have the upper control limit for the chart, and we have the lower control limit for the chart. So if I go back to here, the upper control limit, so the upper control limit, this part is that this is the maximum that you can go. This is the max, and this one is the minimum that you can go for the manufacturing. If anything is higher than this one, it means that it is a problem. If anything lower than this one, it is the problem. So any pressure value, any P value higher than UCL is defective. You can say yes, defective, or you can say that check. Okay, it needs a check, or it needs quality check, we can say. It may be defective. And then any pressure value, any fire extinguisher pressure value that is less than ACL, also it needs to check. So we have to check that if it is okay or not for manufacturing process. So for that one, as I told, you are building a X bar chart. So how we are doing that, I will just go to the Excel and I will do that for you. But from the chart here, you can see that the values are in the range. So it is okay. If we just go with this way, for example, the sample 1, if you go back to here, sample 1, we did 4 measurements. But this doesn't mean that we have 4 of them. We may have thousands of these fire extinguishers, but we just used 4 of them for pressure measurements to check they are okay or not, they are if defective or not. So, and the sample 1, sample 2, all of them, you can see it is in the range. It is not, it is in the control limit range. So that means that the products are okay. There is not any problem. And let's first build the X bar chart, how we are doing the X bar chart and what does it mean. And then I will go to range chart and I will build the range chart for you. Let me open the Excel for you and then start building the X bar chart. Okay, this is the data that we will use, that we have the 23 samples, and then for each sample we have 4 measurements. It is like you are taking randomly samples from a population and then you are trying to understand if they are okay or not. So this is the table that we are going to use, and this is the formula that we are going to use. Then we go to Excel here, and then we have sample 1 and the 4 measurements. We have sample 2 and then 4 measurements. And similarly, we have sample 23 with 4 measurements. Okay. Then the first thing is that for this X bar chart, so we have to first take the average of the values. Average of sample values, I could say. So you will take the average of these 4 values, and then you will do the same process. You take the average of these 4 values in my sample 1, and then you just copy and paste it to all samples. And then similarly, you have the sample, for example, 3, the average value sample 4, and then this is the average of each sample. Okay. And then we are looking for the, you see this one is X double bar. That is the grand average that I talked about in statistics class. So then I will need to find the grand average. So to find the grand average, let me just put it here. X bar, it's also called the grand average. And this will be the average of the average. So I will take the average of the whole average values. Okay. And then I need my upper control limit and I need the lower control limit. The upper control limit is the grand average plus the A2 value, which I take it from the chart. Then I have the average range, and then similarly for lower. So therefore, I need to find the range of my values. Range also in our previous class, in statistics class, I talked about the range. It is just the maximum of the values in the sample minus the minimum of the values in the sample. Okay. You do the same for whole samples, then you can see the results here. So we take the range, and then I need the average range. Average R, or it's also called R bar. Let me put it this one as R bar, and this will be the average of the whole samples here. So what we are essentially doing is that we are looking for the average values. We are comparing the average of sample 1 with the average of sample 2. So for example, if the average of sample 1 is very different than the average of sample 2, or any of the averages, what it means is that we have the problem. This is the main essence of this X bar chart. So I have the R bar, I have the X double bar, which is the grand average, and then I need the A2 value. And to find the A2 value, I go to my table here, and I have the A to D and the B, C values. A2 is here, you can see. This is my A2 value. And then this A2 value, I will need the observations in sample. So for example, in my sample 1, how many observations do we have? 1, 2, 3, and 4 observations. N is 4. So I will go to 4 here. And then for this 4 value, I will just select the A2 value, which is 0.729. So that will be, if I go back to here, A2 value is that 0.729. And then for N is 4. A2 value when N is 4 is 0.729. Okay, And then since I have the A2 value, I have the R bar, I have the X bar, and then I can draw the chart. Okay. So the chart will be based on this X bar. So let me just put this one as X bar. And this one I will put as the range. Okay. So let's first do the X bar part. So I'll just go to the insert, and then I will have the scatter chart. Delete it, it did it automatically. Then I will go to scatter chart. And for this scatter chart, I will select the data and I will add the X values here, which is the samples. And then I will add the Y values, which is the average of each of my sample. Okay, this is how you see. And then you can add a solid line to it, format data series, and then you can add a solid line here. Okay, this is the variation of average of each sample. Okay, and the question is, for example, which one of these is defective? How do I know that? To know which one is defective, I should know the tolerance. What is my upper control limit and what is my lower control limit? If any of these values are outside the upper and the lower control limits, that means that there is a problem with the sample. Okay, so that therefore I will add the upper control limit. The upper control limit is the formula is this one. So let's calculate the upper control limit, which will be equal to the grand average. I will make it $sign because I will use it for wholesale. And then plus the A2 value, again, the $sign, and then multiplied with the range bar value. Okay. Then let me see. Okay, so this one also should be the $. So I will have the upper limit. Okay. And then I will do the lower control limit. This one is just the same formula here, but just it will be subtraction instead of addition. So then I will go to my lower control limit, and then I will just copy and paste the same formula and then put the negative sign here. Okay. And this is the lower control limit. And then let's see if any of our samples is outside the range. So let's add it. I will add the series 2 and the X values are my samples. And then I have the Y values, which is the lower control limit. Okay, which is good. So I don't have any value outside the control limits. Then I will add the upper control limit to see if any of my values are outside the upper control limit. Again, the X values are my samples that I took for measurements. And then Y values are the upper control limits. And then as you can see, all of my measurements are in the range, which is good. Okay, it means that I don't have any defective product, but it is based on the X bar chart. Okay, so I also need to add the grand average, X average of the average. Let's add it, that one as well, X bar. And that one will be equal to, I calculated here, yes, it will be just the $sign here. Okay, I will add that one as well, the select data, and then again I have the X values are my samples, the Y values are the grand average. Okay, this is the chart, and then let's make it a little bit good looking so then we can analyze what's going on here. So I will just put the lower limit as 8, the upper limit, let's put that as 10. And then upper limit, I would just put it as 14. 14.5 was good. Okay, this is how it looks like. And then upper control limit, let's make it a little bit beautiful. let's remove the, and then make the black line so that similarly here. So anyway, you can see the samples that I took to check whether I have defective part or not shows that there is not any defective part. All of my parts, they have a consistent behavior. They are in the range of upper and the lower control limit. And also they are symmetric about the average. You can see they are symmetric. Some of them is, I mean, they are at the same distance. If it is more than average, it is a bit, I mean, if it is more than average and less than average, they are symmetric. So this chart shows that there is no any problem with the X bar values. Okay, let me go back to here. So you can add the sample numbers here. You can show which sample is which, or you can go without it. Okay, and this is the chart that you will always use. This is for the X bar, which is it just compares the average of average. Are the averages in the range or not? In the, let's say, tolerance limit. Tolerance, or you can say that the control limit. Okay, this is the first part that is important for our measurements. And the second part, which is so as I told you, can add the sample, you can search sample here, or you cannot show sample, it's up to you. And another one is the range chart. The range chart, this one, it compares the ranges. And the range is that the maximum minus the minimum. So say that you have a sample one, the range is this much, and then you have the sample two, and then the range is this much, okay? Or you have the sample three, you have the similar range. So here you are just comparing the range. So which one has a different range? For example, sample one here has a different range, yes? So what it means is that there is a possibility that this sample one has a problem with any values. It may be that it includes the defective product. So possibility, it includes the defective product. Okay. Similarly, for the range chart, we are just checking that which of the samples contain the defective part. As you can see, this is the same. Let me just go to the next slide. And this one is for same data for X bar chart. If you go back to X bar chart, the X bar chart did not show any defects. So it did not show any defect. But if I go back to my defective part, if I go to R chart or range chart, you can see that it shows that one of the samples is problem. So sample 10. So there is a problem. There is a problem with one of the samples, okay? And we need to identify, okay, what's the problem here? So we need to identify the problem, okay? And this one also will give us a clear cause. What is the cause for this problem? Also, you can go also I should tell that you have to look for the cause. Okay, what's the cause for this problem? You have to go and identify it. Let me go back to the chart, I mean the sample values, and then look for what is the problem with the sample 10. Okay, if I go back to sample 10, since we are comparing the range, so as you can see, the sample 10, so So we have the minimum as 7. This one is the minimum. And then maximum as the 14 point something. Okay. So the range for sample 1 is too big. Okay, the range is large. So either 7 is the problem, this is very low value, or 14 is the problem, which is very high value. And then you cannot just, I mean, let me go back here, say, and then you cannot delete it, you know. So what you need to is that you need to identify the reason. So first you have to identify the cause or the reason. What's the reason for this high value? You have to identify the cause, and then you can, if you identify the cause, you can either delete it. So you can either delete or keep. Okay. And this point here, which is outside the limit, we call it as outlier. Okay. Because this is outside the limits of our product manufacturing range. So this is our upper control limit, and this is the lower control limit. So that is the reason that I told you that we are using X and the R chart together. We are using the X bar and the S chart together. So we have to use either this, or we have to use this one. Okay. So since in our case, the X bar did not show any problem with our products, but the R chart shows that there is a problem with one of the products here that has defective, that is a possibility of being a defective part. Okay, let me draw it, do this one in Excel as well, the R chart, and then I will move on to the next case, which is the S chart. So to draw it, I will just take the same values in my Excel here. So let me just delete it. So delete these ones too. I have the same data values. I will just need to find the average range. So for that one, I need to find the range. The range, as I told you, is the maximum of the values that I have, then minus the minimum of the values that I have. So I have this is the range for my sample 1. And then as you can notice that sample 10, that it looks like that maybe the defective part, the range is 7 point something. Okay, so it means that there is a problem with here. Okay. And you need to identify, okay, what's the problem here? You cannot just say that it's defective. You have to identify the reason of it. Okay, so then I need to take the average range, which is that, with that, the average of the X range values here. Okay, 2.67. And then I will just take the D4 and the D3 from the chart. So since I will draw a chart, let me just add this average range value here. Then F4. And then I will just use it for the whole column. Okay, and then upper control limit and the lower control limit. Upper control limit is the D4 times R bar. The D4 is you take it from the chart, and for a 4, the D4 value is 2.282. So D4 for N is 4, 2.282. Okay, so upper control limit will be that the D4 times the average value. So I will have this one, which will be the again dollar sign multiplied with this one again with the dollar sign. Okay, and then I will look for the D3 value for the N is 4. The 3 value for N is 4 is that 0. So I will just put D3 for N is 4 is 0. And then I'll just take the lower control limit and then 0 times the average one. And then I will have the full, okay, sorry, it should be the dollar sign with both of them. Okay. So the time is to add the chart here. So let's insert the chart and then see how our data looks like. We have the select data, and then we are adding the X values, which is the range values. And then the X values are the samples. X values are my sample values. And then the Y values are the range values. Okay. And these are the range in my products. So I can see what is the maximum minus minimum in my products. And then format data series, and let's add a solid line here. Okay, then I need to know which one is good or which one is bad, and therefore I need to add the upper control limit and the lower control limit. So then I need to select the data and then add the X values as, again, the sample. And then I need to add my Y values as the upper control limit. Similarly, I will add the lower control limit, the samples, and then the lower control limit. Okay. As you can see, the same chart that I showed you in the slides, that this one is a problem. So that 10 looks like that it has a problem, yes. So you have to go for it, yes. You have to identify what's the problem with this one, what's the problem with this product. You have to identify, check the reason, and then you have to redraw it again. Okay, and then check it has a benefit or not. Okay, then we have the X bar, and I talked about the R chart. Next is that when we have the measurements that is more than 4, or sorry, 10. So in that case, so as you can see, the number of n is more than 10. Okay, n means the number of observations, I would say, or the number of measurements. In that case, you can see I have measurement 1, 2, 3, 4, 5, 6, 7, up to 12, which is more than 10. So if it is more than 10, I cannot use the X bar and the R chart. I have to use X bar and then S chart. S here is the standard deviation. Standard deviation for sample. Okay. So you plot, for example, the same process. You do it for the X bar chart, but here you have different coefficient. You have A3, and then you have the S bar. The S bar is the average standard deviation, average S. I can show it very fast that how do you do this. And similarly, you graph the standard deviation chart. And then you can look for what is so you can see all the products are in the same range, okay, which is fine. Okay, so we have the S bar chart. So let's do it for X bar and the S chart, and then see how it looks like. So I will have the same data points. So let's go for the X bar chart. For the data, the number of measurements is no more than 10. So this is the case that we are looking for. Here you can see the number of measurements in each sample is 4, but here the number of measurements is in each sample is 12. Okay. So for X bar chart, you will do the same, but you only need S bar here. So let me say what's S bar. So firstly, you will find the S, which is the standard deviation. Okay. To find the standard deviation, you just go to STD, and then you will have the standard deviation for a sample. And then you select it. Okay. And then this is the standard deviation for your sample 1. You just go down, and then you have the standard deviation for all of your samples. Okay. And then to find the S bar, you just take the average of the standard deviation of your samples. Okay. You have the S bar, the average of the standard deviations. So again, I will need the X bar. I will need the The grand average, yes. Therefore, I will need the X bar. The X bar is that you will just use the average of, this is the same process, therefore I will do it fast. It's the average of the measurements, and then you just copy and paste it, okay? And then X bar will be that the average of the averages. You take the average of your average values. Okay. And then let's look for the upper control limit and lower control limit. The upper control limit is that you have the A3 multiplied with the S bar. The A3 value, you go again this chart. So you have this 12, which is the one that we have. Okay. A3 for 12 is 0.886. Okay. And then upper control limit will be that this one, the grand average with the dollar sign plus the A3, again the grand average, multiplied with the average standard deviation for sample. Again, the dollar sign. Okay, just do that for upper control limit. The lower control limit is just the same formula here. Just you can copy and paste it with a minus sign. Okay, and that's all. Then you plot it, and then you are done for the X bar chart. But this is for the case where you have more than, the number of data is more than 10, number of measurements. The X values will be again the samples here. And then you will have the Y values as the average, which is the X bar. Okay. Then since you do that, so you can add the upper control limit. Again, you will have let me just go with the Y values. This one is your upper control limit. And then you will have the lower control limit. The lower control limit is this one. Okay. As you can notice, all of the values are in the range. Okay. And you can also add the main average here. So that one will be your X bar grand average, and that will be equal to this one with dollar sign. And then you can add this one to your chart as well. Okay, these are the X values. Okay. All of the data are in the range, and there is no any value that is possibly a defective part. This is for the first chart, and then for the X bar chart, and you can do similar things for the S chart, and then in this S chart, you will just plot the standard deviation values with upper control limit and the lower control limit. Let me do it for you and then see how it looks like. So this one was the X bar chart, and then let me delete, and then so I will have the UCL, and then I will have the LCL, and then this one for, you will take the B4 value, and B4 value for N is 12 is that, so you can just check here, B4 value N is 12 is that 1.646. B4 is 1.646. Okay, this one is for N is 12. And then B3 value for N is 12 is that, so you will have the 0.35354. Okay, then upper control limit will be just the B4 value times the standard deviation here, the average standard deviation. All of them should be in the dollar sign. Okay. And then you have the, similarly for the lower control limit, it will be that the B3 times the standard deviation here, and then you will have the again, the dollar sign. And then you can plot it, and then you can see how it looks like. So you will have the so we have the X values here. And then we have the Y values. This is the standard deviation. Okay, and then you can add the upper control limit will be this one. Then you can add the lower control limit, which will be this one. So are the lower control limits. As you can see, all of the values are in the range. We don't have any value that may look like a defective part. Okay. And if you have an outlier, what you are doing, so say that you have an outlier that any value that is outside the range that I showed in the R chart. So let me just go here. So you saw that one of the parts, this one say that if it is outlier, what you do is that, so if outlier, you have two approaches. The one is that you can remove the outlier and then you can keep the same outlier in X bar chart. The second is that you can remove from both charts. So when you remove outlier, I mean here that remove sample. So what it means is that, say that originally you had the M is 23 samples. We have the 23 samples, but now after removing the outlier, so you will have the M will be 22 samples. Okay, so because one removed. So if you remove one, you will have 22 samples. Okay, and in this case, you will do the whole process again, but now the formulas will be different. So this will be your new formula. So with this new formula, you will draw the same charts, the X bar chart and then R chart here. So you will do the X bar and R chart, and then similarly for if you have n greater than case, 10 case, and if you have an outlier, again, you remove the outlier. Outlier here means that the sample. Okay. You remove the sample and then you draw it again. Okay. So this is the final one. And then you will have the similar homework problems for this topic, and then you will try to draw the control charts, and then you will find you will have the case where you have outliers, and then you will try to identify the reason for that outlier and then remove it and draw it again. So if you have